Hi everyone, we're at the AI Networking Summit, so we're going to record a podcast, a Built for Trust podcast with Soni Jiandani. She's from AMD. Soni is part of the fabled MPLS group. I am so excited to talk to her. She's been involved in so many companies, so many transitions across the years in our industry. She has a great vision of where AI infrastructure is moving to. So we're going to dive into that right now. Soni, I am so happy to have you here. Welcome, on the podcast. It's like, I've known you for so long, and for having the opportunity to just sit down and chat with you is just wonderful.
Thank you for having me here. It's a pleasure, and it's good to be back at ONUG.
Well, we are starting to call it the AI Networking Summit. It's like the whole community has started to shift, towards how AI is impacting everything that they're doing.
That's true.
We're going to get to that, but first I want to make sure, I know everybody knows who you are, but they may not remember this really wonderful storied career. So, how would you like to kind of share, your career with everyone?
Sure. I'm currently the general manager for the networking and technology group within AMD. We are responsible for defining the networking architectures and delivering all networking products across the AMD portfolio, connecting the server businesses, the server technologies, the GPU and AI architectures that are evolving so fast. So we're all things networking within AMD. Prior to that, of course, Mario, Luca, Prem and I, the famous or infamous MPLS crew, crossed numerous chasms. We spent over 2 decades, a little over 2 decades at Cisco, transforming everything from voice over IP and the whole industry of bringing voice video data on a converged Ethernet fabric to also rolling out multiple multi-billion-dollar platforms like the Catalyst, the Nexus products in the switching business, built multi-billion-dollar converged compute network and virtualization platforms through introductions of platforms like the UCS, and then evolved towards everything being software defined with ACI, application-centric infrastructure, which was the last gig that we had before we chose to move and start a company from scratch called Pensando, which has been leading the charter both as a startup and subsequently with AMD on enabling DPUs or data processing units with a very rich software and an architecture that's highly programmable, whereby we are the de facto standard across all hyperscale clouds, and we are powering, our DPUs are powering software-defined network and security and storage architectures for those customers, and you'll be hearing some of that coming out as part of my keynote and customer testimonials. And then finally, we got acquired in 2022 in the middle of the year for $1.9 billion in cash. And now we have the charter and the responsibility to define what the AI network architecture for AMD's platforms and GPUs will be, including the rich software and ecosystem that we are working with to bring this all to life.
Yeah, well, it's as you're talking through that, these are just all the major transitions that happen in the industry, and you and the whole MPLS team has had just such a demonstrable impact on those transitions.
Thank you. Thank you. From my humble beginnings in India, where I grew up, to where it is, I would call it exactly what you just did. And I'm a big believer and supporter of women in technology, and I do make frequent trips back because this is my way of encouraging females in STEM and to encourage the next generation to walk the paths that I was fortunate enough to walk.
Yeah, how awesome is that? Great American story, great STEM story, as well. And just great, good American leaders. That is so awesome.
Thank you. Thank you very much.
So with all of those transitions and all those companies, which ones did you have the most fun in?
Well, to be honest with you, I think Pensando was very gratifying. We had a few headwinds. We got hit with COVID, being a startup. We ran into supply chain shortages. Combine that with the war that broke out. So there are things in business that you control, and then there are things you don't control. And there were a lot of things that we were being faced with, which we didn't have any control over. In spite of that, as I said, we were able to, with the strong leadership and stewardship of John Chambers, who was our chairman, as well as our customers who considered themselves to be strategic partners for Pensando. We were acquired by AMD in 2022. And what is very gratifying is that we can bring to bear, our engineering teams can bring to bear their collective experiences that they've had over the last few decades to do all things great within Ethernet, which now gets to be applied towards AI and networking. And that is essentially the charter we have within AMD, is to bring that next generation architecture to the forefront and build it on standards and an open ecosystem with a talent pool that we have, which has decades of experience across storage area networks and converging that over Ethernet, across voice, across software-defined services, and making programmability, flexibility, and security along with scale as the foundational building blocks.
Yeah, that's great, because like really, if you think about the team, you guys, disrupted actually the compute space.
That's right.
Clearly, you've been like a lot of depth around the whole networking space for a really long time, and even also storage too. So yeah, you have all the major components of AI infrastructure and essentially compute infrastructure.
Exactly,
Yeah.
exactly. It's everything that the application touches that you need to have that level of exposure and experience on.
With all of those transitions that you've been a part of, and also the team that you have, so we're actually we've entered, we're not even at the cusp of it, we are now really into it, a transition of the likes, and probably bigger than we did in the internet era. And we both have been in the industry long enough to kind of actually have had a big impact in the transition to really internet technologies in the 90s. So really, from your point of view, is this bigger? Is it not as big? Kind of how do you measure this transition that we're now seeing towards kind of an AI era?
I think that the internet transition was all about the internet that was going to impact parts of your business and the way you would be conducting your day-to-day life. As John Chambers had said, right? The internet will change the way we work, live, and play in the 90s. If you take a step back, and at that time we all thought that the transition would happen fast, and the rate of change and the increase in infrastructure demands today, if I look at AI, is an orders of magnitude compared to the internet revolution. What do I mean by that? In AI, things are transitioning over a 3 to 5 year period. Vis-a-vis in the internet space, it took a decade and a half for the internet to build out, for applications like WhatsApp to be built on top to deliver voice being free, but yet secure communication where voice, video, data were all coming together, right?
Right.
In this case, we are seeing AI models are growing 1000x every 3 years.
Yeah.
We are seeing that the traffic patterns are growing every 2 years by 10x, by a factor of 10x. And the cluster sizes are increasing 4x every 2 years.
Yeah.
And so at this rapid pace of a change, network evolution from 100 to 100 gig to 400 gig to 800 gig to even 1.6 terabit for Ethernet is going to happen at a much rapid pace than what we saw in the cloud era, for example, and the era of the internet.
Yeah, that's great. That kind of like that jives with I think everything we've been seeing here at the AI Networking Summit, as well. And I think the salient piece of this is really around kind of Ethernet as the fabric, really, to connect all this infrastructure together with.
Exactly. Ethernet, I would never bet against Ethernet of being in this industry for over 3 decades, fundamentally because it has been an evolution and not a revolution. And our customers' operational models, the sophistication and the maturity of the software stack, the ecosystem working hand in hand for decades, and the sheer nature of the way it has evolved are all the elements that are required in my mind to deal with this explosive growth that AI is going to bring.
Yeah, I'm with you on that, because like we have the ecosystem in Ethernet. We have a whole bunch of companies that develop chips. Like obviously AMD is in that marketplace as well. We have such a large knowledge base in this technology that has evolved over time.
That's
and
right.
so, I kind of bet on Ethernet being kind of that fabric component, that is going to tie all this stuff together.
Yes.
So we both agree that this transition is much bigger,
Yes.
much bolder, much faster. than we saw in the previous generation in the 1990s, and even in the cloud era, as well. So you're with AMD now. So what's the kind of the thinking, the strategy around how AMD participates in the AI ecosystem, and in particular Pansendo? So I know you guys are really the focus of the networking piece of it. I know AMD just recently came out with a GPU, as well. So if you can kind of give some thought or share some ideas around how AMD is going to participate in this big marketplace.
So I think if you step back and you look at all the properties of AMD from an AI perspective, it spans all the way from the data center with its GPU and its Instinct portfolio and EPYC portfolio of servers, all the way to the edge. And that's where the real potential of AI will happen. It's going to be end-to-end. The real impact will be felt when you go from the data center all the way to the edges. If you focus your attention more around the innovations that Pensando is bringing from a networking perspective, a lot of our DPU foundational architectures are the foundation that will power the AI networking portfolio for AMD. And the reason is because of really three facets. The architecture is highly programmable, enabling us the ability to accommodate the various evolution and transformation that Ethernet will go through in order to have UEC compliance. And you need it to be highly programmable. Keeping not only the evolution and future-proof aspects in mind, but also the fact that multiple cloud vendors have different versions of transport and innovation across their cloud to accommodate for AI workloads. So it gives us the ability to adapt to the various transports that are out there, again, riding on top of Ethernet in the hyperscalers. The second key element, and the way we have gone about defining our architecture, we have put in a lot of flexibility in the hardware, almost defining Lego building blocks in the networking architecture to give the customers the flexibility to pick and choose how much bandwidth do they want in their clusters for scale out versus scale up. How much oversubscription do you want? Is it a 2-to-1 oversubscription, 4-to-1 oversubscription? So when you have these common elements that you can build as Lego blocks, it gives you the flexibility to standardize on an architecture and the ability to define what your workloads can demand and build to that from a networking perspective. And last but not least, sometimes when you think about a network failure and the impact it can have to the AI workload, you want to have the ability to deal with not wasting your GPU resources should there be a failure, whether there's a link failure or a link flap issue. How does the network converge? And that brings, again, a lot of innovations that are crucial to designing the resilience in the network, which is where the power of this programmable DPU comes about, and the software innovations to allow for running RDMA in a multipathing fabric, so you can converge. It is the ability to support packet spraying and dealing with out-of-order delivery handling. So a lot of things that you take for granted in your transport, you need to bring all those attributes along, keeping in mind your AI workloads and keeping in mind how error handling will be addressed, and providing the reliability, availability to your GPU farms, because that's where you're spending all your money in. And all of your energy is getting conserved, so you want to put those GPUs to use to the maximum potential. And so all the RAS availability attributes is what we are driving, and driving it through standardization of the UEC as well.
I think these are such important points, so like obviously in kind of GPU clusters, it's a very different kind of networking environment. You have kind of spraying, you got elephant, loads, going on. You have congestion management, issues that are very different than we would normally see. Traffic patterns that are very different, as well. The latency component, not even just kind of the latency number itself, but where in the latency, or where in the packet, what's the last packet that leaves the network, because that starts the process in the GPUs. So understanding, that the dropping of a packet too, which is key, because like we would normally drop a packet and we would transmit the entire packet, or the entire packet. Now we can actually pinpoint in what got dropped and just replicate that.
That's exactly right.
And
so that your jobs don't come to a screeching halt, right? Particularly your training jobs, which can take weeks and months. where one hiccup can cause you to have to restart the entire job.
Yeah.
And so the network resilience and all the attributes that you put and the recovery elements that you put within your Ethernet fabric are crucial, which all gets implemented in the DPU.
Yeah, yeah. So the whole programmability of this is really key, because you mentioned the UEC
Yes.
as well, and so that's the group, the consortium that's working on a lot of these standards, and they're
Ultra Ethernet, exactly.
Yeah.
That the goal is again to with the ecosystem, with standardization, you can drive a heterogeneous Ethernet fabric, which most customers want. They they don't want to alienate the Ethernet networks that they have already built.
Yeah, yeah, and I think the bottom line is that I've grown to really appreciate the UEC. It's like that's where we're going to get choice. We're going to get options. We're going to be able to kind of, like, as you mentioned, Lego building block to be able to build these clusters so that you do have options, that maybe you don't have like right now.
Exactly.
Okay. Awesome. So that was really great on all the programmability. So I think that leads me into, like, we're into an area of really highly dynamic change. And so buying something today, you don't want it to be obsolete, within 6 to 12 months. So how do you future-proof this? How do you make sure, like, what you buy today is going to scale with you?
That's a very good question. I think, first, always bet on open standards. Bet on architectures that give you the freedom of choice. And I think all points lead to Ethernet. All roads lead to Ethernet. Make sure that the Ethernet vendor that you're picking, or your partners that play in that Ethernet ecosystem, can deliver for you the choices that you would need. The second thing that I would focus on is consolidation. The rate at which compute architectures are evolving. AMD particularly is leading the chart with its EPYC portfolio, where now you have the ability to drive 8-to-1, 10-to-1 server consolidations. So with consolidation comes the ability for you to have architectures which you are putting in place across your compute fabrics in the data center, and DPU-enabled switches are going to become prevalent. You heard that from Tom Gillis yesterday at Cisco, where they are betting their next-gen security architecture on data center networking fabrics being DPU-powered in the future, so that you can have the adaptability of running security as a first-class citizens on these fabrics, and you get to retire your old legacy appliances, which makes room from a power, efficiency, micro-segmentation, and underlying security elements are secured in that next-generation data center fabric. I think that is an important aspect of consolidation. So you make room for the new age applications of AI. A lot of the enterprises are looking for those killer apps, but by doing this hygienic work around consolidation, you are getting yourselves better prepared. And again, the building blocks and the Lego building blocks will give you the flexibility, depending on the Ethernet vendors you pick and partner with, to get ready for those new age applications within your data center. And last but not least, I would say, think about, how do I deliver scale with flexibility? So today, my compute environments are running at 25 gig. I may be going initially to the public cloud to consume large language models for my AI workloads, but at the same time, there are going to be some highly unique value add data elements that I may want to keep within my own data center premises. And how do I bring in technologies like 100 gigabit Ethernet and 400 gigabit Ethernet in the enterprise? So you want the ability to flex that Ethernet architecture on where you want to run those new age applications, and one that can scale with your growing demands. Okay. So those are essentially the building blocks that I would recommend customers go think about.
Well, I love the idea of the consolidation, because it's simplifying that infrastructure, which is like really key and important, because the infrastructure has gotten so complex with all these appliances into it. So I love that that component, of the vision that you have. And then the scale one is extremely important, because like we are now at unprecedented scale and at unprecedented speed, as well. So I think, it's like the way I kind of sum up, like, your vision is that it's to simplify this infrastructure, and we get a chance to like reimagine what the data center design really is, and we can build it for so that we can deliver a more trusted infrastructure that scales.
Exactly.
I think that is a good place to stop because I know you have to go on stage pretty soon.
Thank you, Nick. Appreciate
Also,
it.
great. Thank you.
Thank you.
Thanks,
Pleasure.
Soni.